Here we have a problem on derivative. Let's go over the question. Use the alternative definition of derivative to find f prime of 2 if f of x equals to square root of 3 negative x. Okay, usually we use the alternative definition of derivative to find derivative of a function at a particular value of x. Here we have to find the derivative of the function f of x at x is equal to 2. Okay, so first let me write the formula for alternative definition of derivative. Here we have the formula for alternative definition of derivative. That is, we have to find the derivative of the function f of x at a particular value of x, that is k. But in our problem, we have to find the derivative of the function f of x at x is equal to 2. That is, we have to find f prime of 2. So for that, what we need to do is in this formula, we have to plug in 2 for this k. Okay, let me do it. So wherever we find k, it has to be replaced by 2. So f prime of 2 equals to limit x tends to 2. So f of x negative f of 2 over x negative 2. Okay, now in the next step, f prime of 2 is equal to limit x tends to 2. Okay, for this f of x, we know the stuff that is square root of 3 negative x. So we can plug in square root of 3 negative x for this f of x. And to get f of 2, what I need to do is I have to plug in x equals to 2 into the given function. When I plug in x equals to 2 into the given function, I'll be getting square root of 3 negative 2 over x negative 2. So f prime of 2 equals to limit x tends to 2 square root of 3 negative x negative. So 3 negative 2 is just 1 and we get square root of 1. Square root of 1 is just 1 over x negative 2. Okay, now in this step, if I plug in the given limit for x, that is x equals to 2, what will happen? So if I plug in x equals to 2 over here, it will become what? Square root of 3 negative 2. So the square root of 3 negative 2 means it's 1. Square root of 1 is just 1. So I get the evaluation of this one for the given limit of x is just 1. And here I have to plug in x equals to 2, then I'll be getting 2 negative 2. I'm getting 1 negative 1 is 0, 2 negative 2 is 0. So I'm getting 0 over 0. It's called indeterminate form in evaluating limit. So when I evaluate a particular limit, if I get 0 over 0, it's called indeterminate form, and this is not the final answer. So we have to ignore this result 0 over 0, and what we need to do is we have to use L'Hopital rule in the last step of the limit. Otherwise, what we can do is we should try to do if there is any possible simplification. I think we can try to simplify the function over here. So whenever I have a rational function, actually here the denominator contains variable x, so this is a rational function, and in numerator we have radical, that is square root. So whenever I want to simplify a rational function which contains a radical either in numerator and denominator, so what we can do is we can take the conjugate of the part where we have the radical. So what is conjugate? Actually, this is here in numerator we have radicals and square root. So what is the conjugate of this one? This one. So very simple. You just have to write the same expression with positive sign at the middle. Already we have negative sign. You just have to change the sign at the middle. When I change the sign at the middle, the expression I am getting is called the conjugate of this one. So to simplify this function, I have to multiply the conjugate of this part in numerator and denominator. So always we have to consider the expression which contains radical to get conjugate. Okay, in my next step, what I'm going to do is I'm going to take conjugate of this part and I'm going to multiply both numerator and denominator by the conjugate of this stuff. Okay, let me do it over here. So f prime of 2 equals to limit x tends to 2 square root of 3 negative x negative 1 over x negative 2. So now in this step, what I'm going to do is I'm going to multiply both numerator and denominator by the conjugate of this expression, that is square root of 3 negative x positive 1 divided by square root of 3 negative x positive 1. Okay, now let's simplify this one. F prime of 2 equals to limit x tends to 2. Okay, now so just look at the binomial over here. So actually the product of these two binomials over here in the form of a negative b times a positive b. So whenever we multiply two binomials like this, that is in both the binomials we have the same terms, but only the sign is different. Here we have negative, here we have positive. So whenever I multiply such two binomials, the product is equal to a square negative b square. Actually, it's one of the basic identities of algebra. Okay, the same thing we have over here. So in these two binomials, we have the same terms, and in one of the binomials we have negative, in the other binomial we have positive. So it is in the form of a negative b, a positive b. So what do we have to write for this product? We have to write a square. Instead of here, we have square root of 3 negative x. So for a square, I have to write square root of 3 negative x a whole square. For b square, I have to write 1 square. And in denominator, I have to multiply the two denominators, x negative 2 and this one. So I'm getting square root of 3 negative x positive 1. Okay, here this square root and square will cancel out. So f prime of 2 equals to limit x tends to 2. So 3 negative x and negative, the evaluation of this 1 square is just 1 over x negative 2 times square root of 3 negative x positive 1. Okay, so when I simplify this positive 3 and negative 1, it will become just 2. So f prime of 2 is equal to limit x tends to 2. So here we can combine this 3 and negative 1, it will become just 2 negative x over x negative 2 times square root of 3 negative x positive 1. Okay, here in denominator I find x minus 2, but in numerator I find 2 minus x. But if I find in numerator also, if I find x minus 2, the x minus 2 in numerator, the x minus 2 in denominator can be cancelled. So for that, I need positive x and negative 2, so that it can be written as x negative 2. So how can I make this negative x as positive x and this positive 2 as negative 2? So for that, I have to factor negative sign from this expression. So whenever I factor a negative sign from a particular expression, the signs of the terms will change. Okay, let me do it. F prime of 2 is equal to limit x tends to 2. Now what I'm going to do is I'm going to factor negative sign from this expression. So when I factor negative sign from this expression, this negative x will become positive x and this positive 2 will become negative 2. And in denominator we have x negative 2 times square root of 3 negative x positive 1. Okay, so even if I distribute the negative sign to this x and negative 2, I'll be getting the stuff over here. So negative times x will be negative x, negative times negative 2 will become positive 2. Okay, now this x negative 2 can be cancelled. For this purpose, and I factor negative sign from this expression. Okay, so f prime of 2 is equal to limit x tends to 2. And we have negative sign over here and 1 in numerator, and denominator we have square root of 3 negative x positive 1. Okay, so f prime of 2 equals to, so that's all the simplification we can do. Now what we can do is we can plug in the limit 2 for x into the function. So when I do so, I'll be negative 1 over square root of 3 negative. So I can plug in this limit 2 for this x, then 3 negative 2 positive 1. So f prime of 2 equals to negative 1 over the square root of 3 negative 2 is just 1. Square root of 1 is still 1. It's positive 1. So finally I'm getting negative 1 over 1 positive 1 is 2. So the value of f prime of 2 is negative 1 over 2.